In the following example, we are asked to find the arc length of the curve. And what exactly is arc length? Well, what I want you to understand here is that the arc length is basically the distance or the length of the curve from one point to another. Okay, so if you're familiar with the distance formula from algebra, you're finding the distance between 2 points. This is kind of finding the distance between 2 points, except the curve is no longer straight. Okay, it's not a line, if you will. So it's irregularly shaped. What we're trying to do is we're trying to figure out, well, how long or how many units long is that? And so we're going to use integration, an application of integration in the arc length formula to find how long that curve is. All right, so we're looking at this example here. I'm not going to graph it. There's really no need. What we're going to do is we're going to apply the formula in order to figure out how long the curve is from, in this case, from 0 to 5/9. Okay, and it's a really nice problem. You're going to realize very quickly that you're going to need an advanced integration technique because it's not as straightforward because of the square root. Okay, so we're only looking at one example here. So here is f of x. All right, here's f of x. It is 3x to the 3 over 2. And then what we're going to have to do is we're going to have to find f prime of x, the derivative. So we're going to bring again the power down, 3 over 2 times the 3x, and then we're going to subtract 2 over 2, which is subtracting 1, so 1/2. So what does this work out to be? 9 over 2 x to the 1/2 power. Okay, and we're going to use that because we need to plug it into the arc length formula L. So we're going to integrate, in this case, from 0 to 5 over 9. We've got the square root of 1 plus, and then it's the derivative, which is 9 over 2 x to the 1/2 square dx. Okay, and so we're going to continue with this concept here before we apply any more advanced techniques. So we get 1 plus 9 squared is 81, 2 squared is 4, so 81 over 4, and then x to the 1/2 squared is just x. Okay, so really nice. Okay, but we realize that it's not that easy to integrate. So what we have to do is a substitution. So we're going to take a look, and I'm going to say, well, let's do u substitution. So u equals 1 plus 81 over 4x. And then I'm going to say, okay, well, then du is the derivative of u, which is just going to be 81 over 4 dx. So we should start noticing, well, we've got 1 plus 81 over 4x. That right there represents u. Okay, what we need is du, which is 81 over 4 dx. So again, as the famous mathematician James Tanton says, he says, if you want something in life, make it happen, but then deal with the consequences. So we're going to want an 81 over 4 right here, but by consequence, we need to write on the outside 4 over 81 because the only thing we can multiply this by is 1. And so we've got that now. Now we've got our du. Okay, but if you recall, when you are doing u substitution with definite integrals, it is very nice to go ahead and kind of adjust your limits of integration so you don't have to back substitute. So we're going to plug in 0 and we're going to plug in 5/9 there, and that's going to alter this. Well, 81 times 4, or 81 over 4 rather, times 0 is 0. So 0 plus 1, 1. The lower bound is 1 on the limit of integration. And then we're going to plug in 5/9. So 81 over 4 times 5 over 9, and then plus 1. Okay, I'll let you do that math, but I've already simplified it. It's 49 over 4. So again, you're going to plug in the limits of integration here, here, and then you get your new limits so that you don't have to go back and back substitute. Okay, that makes it a lot easier when you're doing this definite integral substitution. So we again have 4 out of 81 on the outside. We have the integral in this case from 1 to 49 over 4. So this one we are going to have to plug in. Typically we've had to plug in 0, and that's no consequence, but here we are going to have to plug in both limits and do some subtraction. So let's see here. We are going to have 4 out of 81 on the outside. We're going to have on the inside basically a square root of u, which is u to the 1/2 power du. Okay? And then this is very straightforward to integrate. So we have 4 out of 81, and then u to the 1/2 becomes u to the 1 over 2 plus 2 over 2. That's u to the 3 over 2 divided by 3 over 2, which is the same as multiplying by 2/3, integrated from 1 to 49 over 4. And this, again, adjusting those limits allows us not to have to back substitute, so makes it a little bit faster. So we have, again, our 4 out of 81 on the outside. Now we're ready to plug in. 2 times 49 over 4 to the 3 over 2 divided by 3 minus 2 times 1 to the 3 over 2 divided by 3. Okay. Again, this may not look very fun, but I'm assuming you have a calculator with you, and that will make things nice. So the first part of this, 2 times 49 over 4 to the 3 halves becomes, I believe it's 343 over 12 when you simplify that, minus, and then the next part is really easy. 1 to the 3 halves is 1, so minus 2/3. All right, you do some quick calculations there. You have 4 out of 81 getting multiplied by the combination of those two, the difference, which is 335 out of 12. And you do some reducing, multiplying, all that good stuff. You end up with a final answer of 335 out of 243 cubic units. So this, actually, this is not cubic units. This is just units because it's an arc length. Okay, so think about it. If you look at the formula, it kind of looks like it wants to be a distance formula. Okay, it kind of looks like a distance formula. It's because it's a play on the distance formula. Okay, arc length, again, is the distance between 2 points. And we've been able to do that before, where we found the distance, and the distance formula is exactly the Pythagorean theorem, if you will. So this is connected. And if you can imagine, if you take that curve, if you will, and if you can just straighten it out, well, you'd be able to find the length using the distance formula. That's why this looks very similar. But it is a play on the derivative and then integration techniques. Okay, so you're probably going to have to do u substitution when you're doing problems like this. Of course, your calculator can handle a numeric derivative as well. So this is a little bit on the arc length formula, how to apply it using integration. I hope this video was helpful, and as always, like and subscribe.